Hello everyone, welcome to MathWorld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 6, which is the Probability and Statistics 2 for October-November 2020, and the code is 9709/61. Just for your information, the content of this paper is same as the variant 3 paper. Okay, so which is same as the paper with the code of 9709/63. Okay, so let's move on to question number 1. Question number 1, it is known that on average, 1 in 300 flowers of a certain kind are white. A random sample of 200 flowers of this kind is selected. A. Use an appropriate approximating distribution to find the probability that more than one flower in the sample is white. Okay, so initially this is binomial distributed because your n is 200. Okay, then the p is 1 over 300 because 1 in 300 flowers are white. So that means from here your n times p, that is 200 times 1 over 300, you will be getting 2 over 3. Okay, so we know that when n is greater than 200, when n is 200, this is greater than 50, then the np is 2 over 3, which is less than 5. That means instead of binomial distributed, we will approximate it into Poisson distribution with lambda 2 over 3. So the NP is actually the mean, that is the lambda. Okay, so then from here, I will write the probability of X more than one flower is white. So it becomes probability of Y greater than 1. So for information, binomial is discrete random variable. This is discrete. Poisson is also discrete. So from discrete to another discrete, we do not need to carry out the continuity correction factor. Okay, so just solve as usual. So since this is Poisson distributed now, I will refer to the Poisson formula. Then the formula is going to be E minus lambda x over x factorial. So the x start from 1, 2, 3 until infinity. So now since we do not know when to stop, or the last value of the x, or the last value of the variable, okay, so now when y greater than 1 is actually 2, 3, 4 onwards. So I will use the complementation rule, which means 1 minus all the previous y. So your previous y will be 0 and 1. Okay, and then when you look at the formula here, the E minus lambda is basically a constant. So now I will just write 1 minus E negative 2 over 3. Since this is a constant, I can just take it out, factorize out. So lambda power x, when the x is 0, so any value to power 0 is 1. 0 factorial is also 1. That means the first term left 1, and then followed by 2 over 3 to the power of 1. Over 1 factorial. 1 factorial is 1, no need to write. Then from here, when you minus, that is going to be 0.144. Okay, so that is the approximating distribution. Now B, justify the approximating distribution used in part A. So I will just write n is 200, which is greater than 50. Then NP is 2 over 3, which is less than 5. Okay, these are the justification. Or probably you can just write n is greater than 50 and then the p is less than 1. So up to you. Okay, so now the probability that a randomly chosen flower of another kind is white is 0.02. A random sample of 150 of these flowers is selected. C. Use an appropriate approximating distribution to find the probability that total number of white flowers in 2 samples is less than 4. Okay, so now for the second one, I have to find out what is the distribution first. So now again MP, that is 150 times 0.02. Then I will get 3. Again, this is less than 5. Okay, so your n is more than 50 and then the n is less than 5. Therefore, I will convert it into Poisson. Right, so from here I will say probably this is another kind, right? So I will write just now I use x and y. Probably now here is u, initially u, binomial, 150, 0.02. Now I approximate to w. That is also Poisson distributed 3. So now means now total numbers. So means you need to calculate or get the distribution of y plus w. So the Poisson with mean, previous mean was 2 over 3. So here becomes 2 over 3 plus 3. Okay, therefore, the total is with lambda value of 11 over 3. So now you need to calculate the probability that total is less than 4. So less than 4 means it will be from 0 until 3. Okay, and again use the same formula, that is E negative 11 over lambda. So when the value is 0, I'll get 1 plus when the value is 1, that is 11 over 3 power 1. Then when it is power, when the value is 2 over here, it is 11 over 3 squared over 2 factorial, followed by 11 over 3 cubed over 3 factorial. Okay, so here you will be getting 0.501. So that's the solution of this question. Question number 2. In a survey, a random sample of 250 adults in from Leith were asked to fill in a questionnaire about their travel. It was found that 102 adults in the sample travel by bus. Find an approximate 90% confidence interval for proportion. Okay, for all the adults in from Leith who travel by bus. So now from here, the probability of success, p hat, it will be 102 over 250. Then this is 0.408. So the probability of failure, that is 1 minus 0.408, and you will be getting 0.592. Okay, and now you are forming 90%. So 90% confidence interval for proportion. Formula is p hat plus minus. Okay, now if 90%, for proportion we always use a normal table, means that here is 90%. I will have another 0.1 shared by left and right side. Now here it will be 0.1 divided by 2, that is 0.05, which means I will be getting the total region here is 0.95. Okay, so when you read the table, the normal table, when the probability is 0.95, my critical value 1.645, and this line is going to be negative 1.645. So here is 1.645, then square root of p hat q hat over n. This is the formula. So then I will be getting 0.408 plus minus 1.645, then substitute the values, 0.408 times 0.592 over n is 250. So then from here, to get the lower limits, we calculate using the minus sign, and the answer correct to 3 significant figures will be 0.357, and the other one is 0.459. So that's the solution of part A. B. The survey included a question about the amount X dollars spent on travel per year. The results are summarized as follows. Now given the n, summation x and summation x squared, find unbiased estimates of the population mean and variance of the amount spent per year on travel. So now basically the unbiased population mean, that is mu hat, is same as sample mean. This is same as summation x over n. So I will write 50460 over 250. Then this value is going to be 201.84. And I round up to 3 significant figures, that is 202. Okay, now the unbiased estimate for the population variance. So sigma hat squared. This is same as sample variance. Formula 1 over n minus 1 summation x squared minus square of summation x over n. Then now here when you replace the values, 1 over 249 times 19854,200 minus square of 5460 over 250. Then this is going to be 38832.7, and now I round up to 3 significant figures, that is 38800. So that's all for this solution. Now a counselor wanted to select a random sample of houses. He planned to select the first house on each of 143 streets. Now explain why this would not provide a random sample. Okay, so every house does not have equal chance to be selected. Okay, because we just restricted to every 143. The first house on each of the 143 streets. So it is not each first house, right? So means that other houses will not have the chance to be selected. So it does not have an equal chance of being selected. Right? So this becomes a biased sample already. Question number 3. The masses in kilograms of female and male animals of a certain species have the distributions. Okay, so normal distributions. Now find the probability that a randomly chosen female has a mass that is less than half the mass of the randomly chosen male. So I will write F to represent female, that is 102 mean and 27 squared for the variance. Then the male is M, 170 for mean and 55 squared for the variance. So now you need to calculate probability P, F. Okay, female is less than half of the mass of male, half M. So basically, this is same as probability of F minus half M less than 0. So now I need to find out what is the mean and variance for F minus half M. So the E is the expected value, which is our mean. So this is same as EF minus half EM. Because our formula is expected AX plus minus BY. This is same as A expected X plus minus B expected Y. Okay, then now here, this is going to be 102 minus half of 170. That is going to be 17. Okay, then for the variance, I need to calculate the variance. F minus half M. Then now I have another formula. Variance AX plus minus BY. This is going to be A squared variance X always plus B squared variance Y. So we use the A squared and B squared because the A and B are the multiplication of the X, right? Then from here, you will get variance f plus half squared variance m. Then this is going to be 27 squared plus 1 over 4 times 55 squared. Then you will get 1485.25. Okay, so now since here I will write f minus half m will be with normally distribution, will be normally distributed with mean 17 and variance will be this value. Okay, so now I can solve the question using normal distribution. So for your information, if your x is normally distributed with mean, mu, variance, sigma squared, our standardized normal random variable is x minus mu over sigma. So now here, when I standardize this, I will get z or z less than 0 minus 17 over square root of 1485.25. Then this is going to be less than negative 0.441. Okay, right after this, I will sketch a graph. The symmetrical line is 0, so negative 0.441. Because it's less, so the region is on the left side. And then now I reflect it to be positive. Here is 0.441. So it means that the blue region is basically same as the orange region, that is greater than 0.441. But then the normal table will just give you the region which is less. That means it is 1, total probability is 1 minus all previous regions. So here I will be getting equals to 1 minus P, Z or Z less than 0.441. Okay, then from here you will be getting 1 minus 0.6704 and you will be getting 0.3296. Now round up to 3 significant figures, that is 0.330. So this is the solution of this question. Now question number 4. The diagram shows the probability density function fx of the variable x. The x is from 0 to a, inclusive both. Fx equals to k, this is a k. And elsewhere fx equals to 0 means other x, it will be 0, undefined. Express k in terms of a. Okay, so we know that total probabilities is 1. Okay, because it's given total probabilities is 1, 0 to a, fx dx is 1. That means total area is also 1. Area under the curve. Okay, so from here I know that this is a, here is k. Therefore, k times a equals to 1. Hence, my k is 1 over a. That is the solution for first part. Now, given variance x is 3, find a. Okay, so now I will rewrite my fx is 1 over a when the x is from 0 to a. Right, according to here. So now, variance is counted using ex squared minus square of ex. So now I need to calculate ex first. Your ex is defined as x fx dx. You integrate. That means now here it will be 0 to a, x times 1 over a dx. So the a is a constant, so you can take it out. Integrate x is x squared over 2. Then now you just replace or take out the 2 as well, so it will be 1 over 2a. Then replace the x by a, so a squared minus 0. So at last, I will be getting this is a over 2. That is my ex. Okay, so for ex squared, the difference is integrate x squared fx. Then now here, I will just write 1 over a, instead of x now, becomes x squared. Then here is going to be 1 over a times x cubed over 3, 0 to a. Then the 3 combined with the a, I will get a cube. So at last, a squared over 3. That is my ex squared. And then now variance x is 3, or is ex squared minus square of ex. I will write 3 equals to a cube over 3 minus a over 2. Okay, sorry, I did a mistake. This is a cube. A cube over a, okay, a squared over 3, not a cube. This is a squared. Now to get the a, I will, okay, ex is a over 2, then I squared it. So then from here, I simplify first. This is going to be a squared over 3 minus a squared over 4. So then you will be getting 1 over 12a squared. That is 3. So my a squared is basically 36. Hence my a, right, it will be 6 because when you look at the diagram, obviously your a is positive. So I will not write plus minus 6. Right? Probably here you can write a is plus minus 6, but a is greater than 0. Therefore, your a is 6. So this is the solution of this question. Okay, next question, number 5. The number of absence per week by workers at a factory has a distribution of Poisson 2.1. Find the standard deviation of the number of absence per week. So for information, this is mean and also variance. Okay, so now standard deviation is square root of 2.1. Then you will get 1.449 and round up to 3 significant figures, that is 1.45. Now part B, find the probability that the number of absence in a 2-week period is at least 2. This is per week, right? So then from here, since this is 2 weeks, so I have to times 2 to get the new lambda. That is going to be 4.2. So I will write my y is Poisson distributed with 4.2. And now at least 2. Okay, the number of absence, y greater or equals to 2. So then for Poisson distribution, px equals to x, that is e minus lambda, lambda x over x factorial. So your x will be from 0 onwards. So greater or equals to 2 means 2 onwards. So I will use 1 minus all previous y values. So your previous y values will be 0 and 1. Then here I will get 1 minus e, negative 4.2, then 1 plus 4.2. And here you will be getting 1 minus 0.077977. And now here I round up to 3 significant figures. That is 0.922. Okay, now see, find the probability that the number of absence in 3-week period is more than 4 and less than 8. So now when 3 weeks period, it will be 2.1 times 3. Then you get 6.3. So now let it be W, Poisson distributed with 6.3. Now more than 4 and less than 8. So P, W more than 4, less than 8. So it will be 5 or is plus 6 or 7. Okay, then now just use a formula. E negative 6.3, 6.3 power 5. Because the value is 5, then over 5 factorial. Plus 6.3 power 6 over 6 factorial. Plus 6.3 power 7 over 7 factorial. Then from here, you will be getting 0.4548. And now you round up to 3 significant figures, that is going to be 0.455. That is the value of part C. Okay, now following a change in working conditions, the management wished to test whether the mean number of absence has decreased. They found that in a chosen 3-week period, there were exactly 2 absence. So D carried out the test at 10% significant level. So now, when 3-week period, okay, so go back to the part C. This is 3-week period. That means our lambda is 6.3. Right? So now here, that means that is also the mean, right? Mean for 3 weeks period. So mu equals to 6.3. And now the management suspect, okay, or wanted to test whether it has decreased. So when decreased means that your H1 mu is less than 6.3. That is the alternative hypothesis. And 10% significant level, alpha equals to 0.1. And now here, we always write reject H0 if probability of W, because for 3-week period I use W for the part C. Okay, so I will use back this distribution or this random variable. Now exactly 2 absence. So now since here is less than in the H1, that means it will be less and equals to 2 and less than 0.1. This is the rejection criteria. So now PW less equals to 2, so it will be starting from 0. So your PW equals to 0, PW equals to 1, or PW equals to 2. And now just use a formula. It will be E negative 6.3, then 1 plus. Then here 6.3 plus 6.3 squared over 2 factorial. Okay, then here you will be getting 0.0498. So now you compare with 0.1. So obviously this value is less than 0.1. Okay, so my decision is since the probability is less than 0.1, therefore we reject H0. Because it is clearly stated here, reject H0. So when reject H0 means that now you need to check whether the management's doubts is correct or not. So we have rejected H0 means that there is sufficient evidence to conclude the mean number has been decreased. But remember, this decision or results is only valid at 10%. So there is sufficient evidence at 0.1, at alpha equals to 0.1 to conclude that the mean number of absence has decreased. Okay, so done for this hypothesis testing. Now, E state with a reason which of the errors type 1 or type 2 might have been made in carrying out the test. Okay, just for information, type 1 error, probability of type 1 error is defined as probability of rejecting H0 given H0 is true. Okay, whereas for the type 2 error, it is defined as except H0 given H0 is false. So now, by looking at the decision in previous part, because we have rejected the H0. Okay, so when we reject H0 means that it satisfies the type 1 condition, right? So therefore, you just write H naught was rejected in parts D, hence type 1 error. Have been made. Okay, so done for this question. Okay, now question number 6. The time in minutes for Anjan's journey to work on Mondays have mean 38.4 and standard deviation 6.9. A. Find the probability that Anjan's mean journey time for a random sample of 30 Mondays is between 38 and 40 minutes. So this is the distribution of mean, right? So then I will just write the X bar will be normally distributed with mean 38.4, standard deviation 6.9, so 6.9 squared over 30. So we are using this formula. Okay, so later when you standardize, it will be X bar minus mu over square root of sigma squared over n. So then with this, you need to calculate probability that's between 38. See the mean time, right? So X bar between 38 and 40. So this is going to be P 38 minus 38.4 over square root 6.9 square over 30. And then this is the standardized normal random variable. Then the maximum value 40 minus 38.4 over square root of 6.9 square over 30. Okay, then from here you will be getting probability of negative 0.318 and 1.270. Okay, between these two values. So now, when we refer to the graph, right after this will be the graph. One is negative and the other one is positive value. So to find this region, I will say it is Pz less than 1.27 minus Pz less than the negative value. But for the negative value, we have to sketch another graph. Because the negative value, the region is not available in the table. So negative 0.318. Less than means towards left side. So this region will be reflected to be the positive value. So the blue region is same as the orange region. So now here, the orange region is basically total probabilities 1 minus Pz less than 0.318. So I will direct change to that form. Then now, refer to the table. The first probability is going to be 0.8980. Then the second probability, you will be getting 0.6247. Okay, so with this, you will be getting 0.5227 and round up to 3 significant figures, that is going to be 0.523. So that is the solution of this question. Now, engine wishes to test whether his mean journey time is different on Tuesday. He chooses a random sample of 30 Tuesdays and finds that his mean journey time for these 30 Tuesdays is 40.2 minutes. Assume the standard deviation on Tuesday is 6.9. This is the standard deviation. B, first part states with a reason whether engine should use a one-tail or two-tail test. Okay, whether his journey is different. So when different means it must be two-tail test. So here should be two-tail test. Because engine is looking for difference or change. Okay. Now, part 2, carry out the test at 10% significant level. So now, H naught, the mu initially, okay, let's check. The mu is 38.4. This is for Monday. Now on Tuesday, whether there is a change, so not equal to 38.4. And then the alpha is 10%, 0.1. Okay, so from here, we'll look at the question. It is 30 Tuesdays, right? And then it's mentioned that mean and standard deviation. Okay, so from here, because of 30 Tuesdays, right? So we will be using normal distribution. So then according to the central limit theorem. So then from here, I will just draw a graph to show the rejection region. Now, based on the H1, since this is not equals to, means that it will be two-tail test. So the total regions of left and right side will be 0.1. So which means now here, I know that this is 0.1 divided by 2. Okay, each side is 0.1 divided by 2. That is 0.05. So which means here is 0.05. And then now, for the normal table, you are given the regions towards the left side. So that means here is 0.95. So now when you look at the table, the critical value is going to be 1.645. So one is negative and one is positive. And then from here, I will be writing the rejection region. Reject H naught if modulus of Z is greater than 1.645. And now my calculation. So the Z equals to X bar minus mu over square root of sigma squared over n. Or you can write sigma over square root n, no problem. Then here is going to be, okay, X bar the mean for 30 days, 40.2. So I will write here 40.2 minus a mu. Mu is a mu at the H naught, that is 38.4 over square root of, the variance is 6.9 squared. And again 30 days, okay, 30 Tuesdays, so over 30. Then here you will be getting the answer of 1.429. Right, so basically you can round up, it will be 1.43. 3 significant figures. So now mark this value on the diagram, on the graph. 1.43 is basically outside the region. Okay, here is 0. So from here, since the calculated value is less than 1.4645, so we do not reject H naught. Okay, then if do not reject H naught means that insufficient evidence to conclude the H1. So there is insufficient evidence at 10% significant level. So at alpha equals to 0 0.10, 0 0.10 to conclude that the mean time has changed. Okay, so this is the hypothesis testing in part 2. Now part 3, explain whether it was necessary to use the central limit theorem in B part 2. Okay, so as I've mentioned just now, when you look at the question, right, you are given the mean and standard deviation, and then you are not given the distribution. So from here, that means we have to refer to the sample size. As long as the sample size is at least 30, then we are going to use normal distribution due to the central limit theorem. So now part 3 is asking whether it is necessary. Explain, right? Explain whether it was necessary to use central limit theorem. So the answer is yes, because the population distribution is not given. The population's distribution is unknown. Okay, so that is the reason for using central limit theorem. Okay, so I have completed this paper and also comes to the end of the video. Thanks for watching, and again, please subscribe to the channel and share this channel with everyone if you enjoy watching my videos, and also stay tuned for more upcoming videos. Thank you everyone. Bye.